Hello students, this video clip will be reviewing the diversification of portfolio with two stocks. Question number 1. Compute portfolio 50% and 50% rate of returns and risk based on the case probabilities. So we have two totally the different types of stock, auto stock and gold, which is the real asset. And the three different types of economies, the recession case, normal case, and the boom case with different probabilities. So the auto stock usually make more profit, definitely on the boom case of economy, but the gold stock or gold real asset make a profit under the recession because usually the investors want to retain their asset to the real asset, reserve the real asset. So usually under the recession, gold stock make a profit. So they are totally showing the different movement, the auto stock and the gold stock. Question number 2, find the optimal weight of investment that has the lowest the standard deviation of portfolio. The reason why we want to make the portfolio in a pool of investment is to reduce the risk of the investment, maintaining a certain level of the expected rate of return. So the expected rate of return of the auto stock and gold stock, combining these two, we will come up with expected rate of return of the portfolio, and then the standard deviation. We want to find the lowest standard deviation as possible. Okay, and then number 3, the calculated correlated of two stocks. So let's start from the expected rate of return calculation on the auto stock. 8% minus 8%, 5 and 8% under the different cases of economy. So this 20% times minus 8% under recession plus 50% times the 5% plus 30% times 80%. But much simple function is the sum product. Just you can use sum product. Then the probability and another array is the rate of return. So we got the result. In the same way, sum product of gold stock is the probability and the gold. So sum product. Okay. So the negative is 0.5%. And the variance of the auto stock, how do you get it? If you just use the variance population and drag this number, that is the wrong answer. Because the rate of return has different probability. So we want to use some procedure, long way to go. So minus 8%. We call the minus 8% from the expected rate of return. That is the distance. But if the distance have the negative amount, it doesn't make sense because distance doesn't have negative distance. So we want to remove the negative amount putting to the power of 2 and times the probability, and I want to fix it to use this function on the gold, the variance calculation, plus the same way, the 5% minus the expected rate of return and to the power of 2 and times the 50% probability with fixed and plus the distance of the boom case of the rate of return, 18% minus 6.3 to the power of 2 to remove the negatives and times now the boom case. So we got the variance 82.81, and then let's just drag 204 is the variance, but the variance is not a perfect the risk measurement. We understand that the variance of gold is greater than the variance of the auto stock, but it shows the percentage and percentage times the percentage, because we multiple this distance to the power of 2. So the standard deviation is the more give us more sense. So standard deviation, how to get it? The square root of this variance. So the square root of this variance. So 5% standard deviation on the auto stock means from the standard, which is the expected rate of return, 6% up by 9% and down by 9%. That is the deviation, the risk. And the standard deviation of the gold, the asset is 14%. The expected rate of return is minus 0.5%, up by 14, down by 14. So it's much variance. It has much variance. So if we combine these two totally opposite the type of stock into a portfolio with 50% and the 50%, but I want to use here 1 minus the 50% of the auto stock, because when we come up with the lowest standard deviation, we will change this 50%, and then the gold weight will be automatically changed. Okay. Then recession case. Then how do you get the rate of return of portfolio with this 50% and 50%? I want to fix this 50% weight times the gold stock under the recession 8% minus 8% plus the 50% with fixing and times the gold stock 20%. Got it? So we got 6% under the recession of the rate of return portfolio. Now let's drag down. So we got the three different the rate of return under the recession, normal, and boom case of the return of the portfolio. And the expected rate of return now is, one more time, the 20% probability times the 6% the rate of return of portfolio plus 50% probability times 4% rate of return of portfolio plus 30% probability under boom case times minus 1%. Then 2.9% is expected rate of return we want to maintain regardless of what the economic circumstances that changes. Okay, so the variance, how do we get the variance now? The same way, the 6% minus 2.9% of mean to the power of 2, and we need the probability now. Plus, now the distance of the normal case minus from the mean, which is distance, to the power of 2, and then multiple the probability under the normal case, plus, one more time, the last, minus 1 minus 2.9, the distance under the boom case to the power of 2 times the boom case probability. So the variance is now significantly reduced under the return of portfolio. So 7% and percent, then the standard deviation square root, how to get it? Standard deviation is now 2.66. Ooh, that's the amazing result, because 2.66, now that means that regardless of what would happen on the economy, this 2.9% will be deviated up by 2.66 and down by 2.66. So this portfolio won't lose any money. Okay, so 2.66 is the standard deviation of the portfolio, but the question is asking the lowest standard deviation as possible. So we want to find some weight, the optimal weight of the auto stock and gold stock that makes the lowest standard deviation of the, ideally like zero standard deviation. So in order to find this, the lowest standard deviation, in order to find the weight, optimal weight that produces the standard deviation lowest, so we use the goal-seek. So data, what if analysis, and the goal-seek, then set the cell. We want to get this value, the standard deviation, to the value 0 as lowest as possible. By changing cell, what do we want to change? Okay, here we want to change auto stock so that the gold stock, the asset, the weight of gold, the asset is automatically changed. Okay, you guys remember we set up this 1 minus F11. So let's do this work. Then Excel is finding the optimal, the weight of the stock, two stocks. Okay, now the Excel, the goal-seek status defines 0.61. Anyway, the 0 is not possible in this case, but the almost is the close to 0, 0.61. So 61.95% auto stock weight and the gold stock 38.05%. That makes the standard deviation of the portfolio the 0.61. So, okay. Then the correlation between two stocks. Number 3 question is just correlation. Correlation. Just you can just drag these two stocks. So the order doesn't matter. So we found almost one correlation that makes the standard deviation very low. Okay, because the one stock and the other stock are moving totally different directions. So the expected rate of return 3.71% and the standard deviation 0.61. That means that regardless of what economy situation the changes, this portfolio can maintain 3.71% rate of return, and with the deviation up by 0.61, down by 0.61. So it's almost the stable, the expected rate of return using these two the stocks. Okay, that's it. See you the next video clip.